All right, we are going to take a little break in Chapter 11 here to throw in the section 5.7 that we skipped over earlier this year. We saved this one and put it with Chapter 11 because it affects what we're going to do in our next lesson. Okay? We are going to be looking at something called the binomial theorem, and we're going to use it to expand a binomial. Remember, binomial means you have two terms? So we're going to be taking things like a plus b to some kind of power. Okay? And how do we expand those out? All right? And again, this is going to work into what we do tomorrow in section 8 when we talk about binomial probabilities. All right? We want to be able to expand a binomial. All right. It is based off of some work from Blaise Pascal. Back in the 1600s, he developed something called the Pascal's Triangle. And we will be looking at that and all the little criteria that creates that, right? All the patterns that we see in it. So, it says you can use a pattern of coefficients in the pattern a to the nth, a to the n minus 1 times b, a to the n minus 2 times b to the second, etc., to write an expansion of a plus b to the nth power. Now that sounds complicated, but again, there's lots of little patterns. If you recognize the patterns, it's actually very easy to do. If we have a plus b, I'm going to back up even one step here. What happens when we take something to the 0 power? Anything to the 0 is 1, right? So if I have this quantity a plus b and I'm raising the whole quantity to the 0 power, I'm just going to get a 1. Okay? If I take a plus b to the first power, does that do anything? No, it's still a plus b. If I take a plus b and square it, do you guys remember the pattern we had for that? What happens when we take a plus b times itself? If you don't remember, you can write it out. A plus b times a plus b. What would we get? A squared. What happens with insides and outsides? They don't cancel because we don't have opposite signs. In both cases, we get a times b. Yes? So we're going to have two ABs. And then last piece would be b squared. Remember the pattern was square the first, twice the product, square the last? Okay. How could we do a plus b to the third power? What does it mean to raise something to the third power? Times itself 3 times, yes? So we would have this, a plus b times a plus b times a plus b. If we had to do this by hand, could we take the answer we just came up with for a plus b squared and multiply in a third a plus b? Okay. If we did that, we said this first chunk here gave us a squared plus 2ab plus b squared. What do I get when I multiply this together now? A squared times a is a cubed. A squared times b. Okay. Second term, I'm going to take 2ab times a. That's going to get me 2a squared b's. 2ab times a b is 2ab squared. B squared times a and b squared times b. And if I put like terms together, I'm going to get 3 of these pieces and I'm going to have 3 of those pieces, correct? So it simplifies down to a to the third plus 3a squared b plus 3ab squared plus b cubed. Okay? If we had to raise it to the fourth, we would have to take the answer I just wrote there and times it by another a plus b, correct? And if we wanted to continue expanding these, we'd have to keep multiplying another a plus b in there. That's a lot of work, especially if I said take a plus b to the 11th power. Okay, you'd be working at that for a while. So we do have a shortcut. I'm going to have you go ahead and put down the fourth one here. We'd have a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth. Okay. I'm going to pause the recording for a minute. I want you guys to look at the powers and see if there's a pattern with the A's and the B's. Okay, talk at your tables. All right, so in your groups, some patterns that you came up with.
The B's go up.
The power of B goes up. Okay, so let's look at the red one here on the bottom that's got the most. So here we had B to the first, second, third, fourth. What would this first one be? If we needed a B in there, could we say B to the 0? Would that work? Okay, what about the A's? You said the B's power go up. What happens to the A power? It goes down. Yes? Okay. In this last one, we started with an a to the fourth, b to the 0. Our powers add up to 4. In our next term, we have a cubed b to the first. Our powers add up to 4. In our next term, a squared b squared. Our powers add up to 4. What were we raising it to? Fourth power. Yes? Does that same pattern hold in the other ones for the cubes or the squares? We still have the a power going up by 1. Sorry, going down by 1, and the b power going up by 1? Okay. And within each little grouping, the powers add up to what you were trying to expand it to. Yes? Okay. So there's some patterns with the variable parts. If you take all of the variable pieces out and you just look at the coefficients, it turns into this. Okay? This is the start of Pascal's triangle. If we are taking something, a binomial to the 0 power, we said we just got a plain 1, correct? When we had a plus b to the first power, we just had a to the first plus b to the first. The coefficients on both of those were 1s. Yes? Okay? As we keep going, our coefficients are 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Okay? Those are critical to expanding a binomial without having to do all the little work of expanding it by hand. Okay? Looking at our coefficients. We start out, the first row is a 1. Do you notice that the very first and last number in every row is a 1? Okay, that's a pattern you have to recognize. Within those 1s, what happens if I add those together? I get a 2. If I add the 1 and the 2 together, I get a 3. Yes? If I add the 2 and 1 together, I get another 3. If I add these 1 and 3's, I get 4. 3 and 3 is 6. 1 and 3 is 4. So to create any row, I know that it has to start and end with a 1. And all the numbers in between, I'm just going to add the ones above it. So what would my next row look like? A 1 on the outside, and then 5, 10, 5, and 1. Yes? Sorry, I missed a 10 in there, didn't I? Thank you. 10, 5, and then a 1. Yes? Could you keep generating the next rows? Yeah, we could keep going forever. Pascal's triangle is going to help us find those coefficients of all the little pieces in our binomial expansion. Okay? All right, we generated the next row. That's enough. So this one goes up through what we would call the 8th row. This first one here, we call row 0, right? We took a plus b to the 0 power, we just get a 1. This would be row 1, row 2, row 3, etc. This would be the 8th row. So when I tell you you need to find the 8th row, how are you going to know which one it is without all your counting? 8 is the second number. Look at that second number, right? Row 2, row 3, row 4, row 5, row 6, row 7, row 8. Okay? So if you need the 8th row, you got to find the row that has an 8 in it. Does that make sense? Okay. We are going to start out expanding one that's just an a plus b. Very basic binomial. We are going to raise it to the 6th power. If we need to raise it to the 6th power, I need to find the 6th row of Pascal's triangle. So look at Pascal's triangle and give me the numbers in the 6th row. 1, 6. Okay. All right. That is the first piece to finding each of my terms. Okay? Now, you guys said that the a power went up or down as you went through your polynomial. It went down, right? It started with the highest power and went down. So my a is going to start out with the highest power, which is a 6, and then it's going to go down. And what happens to the b term? The power goes up. So my b is going to start out with a 0, and it's going to go up each time. Now, what you're going to do with each of these pieces is multiply them together. So I'm going to take 1 times a to the 6th times b to the 0. Well, what's b to the 0? 1, right? Anything to the 0 is 1. So this is really 1 times a to the 6th times 1. What are we going to get? A to the 6th. Okay? My next row, I'm going to take a 6 times a to the 5th times b to the 1st. So I'm going to get 6 a to the 5th b. My next row, I would have what?
15.
B squared. Okay, next one, somebody else? 20. Okay, a cubed, b cubed. Next row? b to the 4th. And next row? 6a b to the 5th. And last row? It ends up being just b to the 6th, right? Because a to the 0 is 1. 1 times b to the 6th. Those pieces are each of the terms in my polynomial. Okay? When I expand a plus b to the 6th power, I'm going to get each of those pieces. So I have a to the 6th plus, my next term was 6a to the 5th b plus 15a to the 4th b squared plus 20a cubed b cubed plus 15a squared b plus 6ab to the 5th plus b to the 6th. Okay? Now, what makes it a little trickier is that we don't always just have a plain a and a b. Did I miss something? Thank you. What makes it tricky is that we don't always have just a plain a and a b. I could say take 4x plus 7 to the 5th power. Yes? You're going to follow the same patterns, it's just you don't have a plain a and a plain b. Okay? I like to write them out in rows like this, so each term is a separate row. Because what happens is if you start listing all of your coefficients, and then you go back and try to put in all your a's and then all of your b's, and you've already written it out horizontally, you end up running out of space and everything gets crammed in and it's hard to tell what's what. Okay? So I'd like you to write it out as one row for each term and then string them all together at the end. All right, so let's try one that has a little more involved in it. We are going to expand something like this. Okay? The formula that's listed up here is the formal way of writing our binomial theorem. All right? The p's in this pattern stand for the numbers in Pascal's triangle. And notice your powers for a go down. We have a to the nth, then a to the n minus 1, a to the n minus 2. Your b's go in the reverse direction. It ends with b to the nth and works backwards. Okay? So again, that's kind of the formal way of writing what we've just been talking about. Where most students run into trouble is you're expanding something that's not strictly an a and a b. Now we start throwing some numbers in there. Make sure that your term is put in parentheses when you write it out. Make sure if there is a minus sign that you tack it on with the second, with the b term. So when you look at this, x minus 2 to the 4th power, what we used to call a is now going to be an x. And what we used to say as b will now be a negative 2. Does that make sense? Okay. This is another place that students often make a little mistake. If you're taking 3x to the 4th, remember you have to raise the 3 to the 4th as well as the x. All right, you have to distribute that power. All right, so let's try one that has a little more involved. We are raising it to what power? The 5th power. So which row in Pascal's triangle do I need to find? The 5th row. It's going to start with what? A 1 and then a 5. So look at Pascal's triangle and find the row that starts with 1 and 5. What are my coefficients? 1, 5, 10, 1. Okay. Before we go on, we've been talking about patterns. Did you notice anything in the rows of Pascal's triangle? Do you see any symmetry in the rows? Right? 1, 5, 10, and then it reverses 10, 5, 1. Is that true in every row? Yes? Okay. So we've got our coefficients. Next, we're going to multiply by our first term. What's our first term in this case? The 3x. So we're going to take 3x. Each one of these pieces is going to need a 3x. And what did we say happens to that first term's power? Does it start high and go low? Does it start low and go high? Starts high and goes low. So what's the highest number? What are we raising our binomial to? A 5. So we're going to have 5, then 4, 3, 2, 1, 0. Okay. Our second term is what? is a negative 2. All right, you got to tack that negative on with the 2. So we're going to need a negative 2 in each of these. All right, and we're going to raise it to what power first? 0, and then 1, 2, 3, 4, 5. So this is the first step. Just get everything set up. Then we're going to take each row and we're going to figure out what that simplifies down to. Okay? So we have a 1 times 3x to the 5th. That means I have to take 3 to the 5th and x to the 5th. What's 3 to the 5th? 3 to the 5th. Grab your calculators or your power charts. What is it? 243. So 243 x to the 5th. And what is negative 2 to the 0? Anything to the 0 is 1. So when I multiply these all together, 1 times 243x to the 5th times 1, I get 243x to the 5th. Yes? That's going to be the first piece of my answer. My next piece, it says take that 5, multiply it to 3x to the 4th. Well, 3x to the 4th means I'm raising 3 to the 4th and x to the 4th. What's 3 to the 4th? So I have 81x to the 4th, and negative 2 to the 1st is still negative 2. So 5 times negative 2 would be negative 10. Negative 10 times 81 would be negative 810 x to the 4th. Okay, that's my second term, negative 810 x to the 4th. My third term, 10 times 3x cubed. What do we get? 27x cubed. And then negative 2 squared becomes positive 4. All right. So we need 10 times 27 times 4. What do we get? 1080. And it would be x to the 3rd. So my third term is going to be a positive 1080 x cubed. All right, my next one. I have a 10 again. This time I'm taking 3x and squaring it. So I have 9x squared. And I have negative 2 being cubed. What's negative 2 cubed? Two times 2 times 2. Negative 8. All right. What's negative 8 times 9? Negative 72 times 10 would be negative 720. And it's x to the 2nd. Okay? Next term. I have a 5. I'm multiplying it to a 3x to the 1st, so I'm multiplying it to 3x. Then I'm multiplying it to negative 2 to the 4th. If I take a negative to a 4th power, it becomes positive. 2 to the 4th is 16. So what's 5 times 3 times 16? All right, x to the 1st. And last term, I have a 1 times, what's 3x to the 0? 1 times, what's negative 2 to the 5th? So multiplying, I get negative 32, and that's my final term. So this polynomial on the bottom here is my final answer to the expansion of that. Okay? All right. Our last one. I did make one little change. I want you to put a little y on the end with that 3. We're going to get this started, and then I'm going to give you a chance to try it on your own. Which row do I need to start with in Pascal's triangle? The 4th row. So I know it's going to start with a 1 and then a 4. What's the rest of it? 6, 4, 1. Okay. What is the first term? So what is like the A in my pattern? Okay. So I know that I'm going to need a 2x in each of these. And what power do I start with? A 4. And it's going to go down from there. Okay. What's my second term? Negative 3y, and it's going to start with what power? 0 and then go up? All right. Finish writing it out and then simplify each term. All right. Check your setup. Make sure that you have things, the pieces put in there correctly. Each of these rows becomes one term of my answer. So this becomes 1 times 2 to the 4th and x to the 4th. 2 to the 4th is 16. So x to the 4th. And then negative 3y to the 0 power is just a 1. When I multiply those, I get 16x to the 4th. That's the first part of my answer. My next row, I have a 4 times 2x cubed. 2 cubed is 8. Negative 3y to the first is negative 3y. Those pieces need to get multiplied together. What's 4 times 8 times negative 3? Negative 96. Then your x's, we have an x to the 3rd, and we have a y to the 1st. So negative 96 x cubed y is my next term. Next row, I have 6 times 2x to the 2nd power becomes 4x squared. Negative 3y to the 2nd power becomes 9y squared. What is 6 times 4 times 9? 216. My variable pieces, I have an x squared and a y squared. Next row, 4 times 2x to the 1st. Negative 3y cubed becomes negative 27y cubed. Again, we are multiplying all of these things together. We should get negative 216xy cubed. And the last piece, we have a 1 times 2x to the 0 power, which is a 1. Negative 3y to the 4th power is 81y to the 4th. We end up with 81y to the 4th for our final term. Okay? All right, so your homework today, you are going to do page 329, questions 12 through 19. That's the binomial expansion stuff. Then I'm going to give you guys a worksheet. You are only required to do the side labeled 19.2.